I think we all agree that humans are intelligent. Now, why don't we just give this intelligence to computers so that they can see the world too and perhaps behave like humans? But the concept of intelligence is pretty vague and complicated. For example, if you measure intelligence by how fast someone is able to perform mathematical calculations, then computers are already way smarter than humans are. But we don't see Terminators on the street. But if you think about it, you realize teachers don't give knowledge or skills to students, they teach them. So maybe instead of trying to give intelligence to computers, we should be trying to teach them too. Let's say I want to teach my computer what a cat looks like so that the next time it sees a cat, it can say, "Hey, that's a cat." And what I'm going to do is show the computer a bunch of cat images and say, "Hey computer, that's a cat, and that's another one, and this one too." And each time I show the computer an image of a cat, it's going to figure out features or patterns in these images that makes it a cat. And if we show the computer an image of a cat that it has never seen before, it will still be able to classify it as a cat based on the features that it has learned before. But how does the computer learn these features from our images? To figure that out, we're gonna switch things up a notch. Let's say we have a machine that outputs values between 0 and 1 for a given image. We want it to return 1 if it's the image of a cat and 0 otherwise. Our input looks like this. It is a cat to us, but to our machine it's just a bunch of numbers that represent the intensity of the pixels across the red, green and blue channels. And inside our machine we have many knobs that range from 0 to 1 arranged in layers that are connected by strings that we'll call weights. The first layer is called the input layer and we'll set the knobs to equal the pixel values of the cat image we saw before, basically providing an input to our machine. Now we'll take the knobs of the first layer, multiply them with the values of the weights attached to them, add to them a value called the bias and pass it on to the next layer, from where we'll do the same and pass it on to the next and so on until the output layer, where we'll have just one knob whose value will be our result, which in this case we want it to be 1 since our image was a cat. This step is called forward propagation. But we have initialized our weights and biases to random values because we don't know the right values that will give us the right results. And consequently, our output will also be some random number, like say 0.5. Now we need to find the set of weights and biases that will give us the right results with a reasonable accuracy. To do that, we take the predicted value and our actual value and calculate a distance between them called the loss. The closer the predicted value is to the actual value, the lower the loss, and vice versa. Next, we try turning our last knob just a little bit and get a feel for how the loss changes with it. And since our knob's value is calculated using the knobs, weights and biases before it, we can figure out the sensitivity of the loss with respect to changing them too. So we move backwards through our layers, figuring out how all of our knobs, weights and biases affect our loss, and then using that information, we will update our weights and biases in such a way that our loss decreases. And in effect, our predicted value comes closer to the actual value, leading to a correct classification. This step is called backpropagation. These weights capture the patterns in our images and allow us to classify cats that our machine has never even seen before. And with that, you now know the basics of deep learning. Thanks for watching.